So in the next 2 units, we're going to be discussing electricity and electrical charge. So in this unit, we're actually going to discuss static electricity, and then in the next unit, we'll talk about current and current electricity. So in order to talk about static electricity, we really need to start to think about where does electrical charge come from. And electrical charge actually arises from the transfer of electrons. So electrical charge results from the transfer of electrons. Now remember that in chemistry and in biology and other classes, you start to learn about the idea of atoms, and all matter is made up of atoms, and atoms have 3 subatomic particles. There are neutrons and protons, which these are tied up in the nucleus of the atom. Neutrons have no charge, protons have a positive charge, but these are sort of restricted to the nucleus. And then we have the electrons, which are negatively charged. Okay, so we usually write it like that. And these are outside in clouds or in shells. And so the electrons are the ones that are able to move from one object to another, therefore resulting in either a net positive or a net negative charge. You may also recall, if you've taken chemistry, the idea of ions. So if we gain electrons, so if a substance gains electrons, it becomes negative because you've added something negative to it. So if you gain electrons, you become negative. And if you lose electrons, now you're going to have more protons than you do electrons making up that matter. So you actually become positive, which sometimes isn't very intuitive because you're gaining something but you're becoming negative, and you're losing something and you're becoming positive. But remember that what you're gaining or losing is a negatively charged object, right? So charge actually has a value, and the idea of, or the unit for charge is coulombs. So the variable that we use is Q. So sometimes you'll see it as little q or big Q, and this means charge, okay? And the unit is a coulomb, all right? Which we usually see with the capital letter C, okay? Now, little q typically is like a point charge, and that's where we're talking about an electron or a proton, whereas big Q is like a bigger object that's made up of multiple atoms, and therefore there's like a net charge. So usually it's some larger net charge, okay? Now, protons and electrons have the same magnitude of charge. So the charge of a proton and an electron is 1.6 times 10 to the negative 19th coulombs. So for a proton, we would say it's positive. For an electron, we say it's negative 1.6 times 10 to the negative 19th coulombs for an electron. Okay, but the same magnitude. Okay. Now, if we were then to take the inverse of that, we could figure out, okay, well, how many electrons make up 1 coulomb? So if we do the inverse of this number, we get the number of electrons that make up a coulomb charge, and it's actually 6.28 times 10 to the 18th electrons in 1 coulomb. So we're talking about a huge number of electrons that make up a coulomb of charge. Right? Now, in the next video, I'll go ahead and I'll talk about actually how we go about charging objects or giving objects a net charge.